Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/JEDI. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars for exams P, FM, IFM and LTAM that I teach, and links to the places where you can buy the study manuals for exams P, FM, IFM and LTAM that I wrote. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P. A company insures homes in 3 cities, J, K, and L. Since sufficient distance separates the cities, it is reasonable to assume that the losses occurring in these cities are independent. The moment-generating functions for the loss distributions of the cities are mj of t equals 1 minus 2t to the negative 3, mk of t equals 1 minus 2t to the negative 2.5, and ml of t equals 1 minus 2t to the negative 4.5. Let x represent the combined losses from the 3 cities. Calculate E of x cubed, the third moment of the probability distribution of x. And here's the solution. So x is what we want to study, where x is j plus k plus l, and I distinguish between random variables j, k, and l and names of the cities by having random variables in italics and the names of the cities, or that notation for the cities in regular letters. So j, k, and l in italics represent the losses in cities j, k, and l respectively. And we are told that these random variables j, k, and l in italics are independent. Therefore, the moment-generating function of their sum is the product of moment-generating functions. So it is equal to 1 minus 2t to the negative 3 times 1 minus 2t times to the power of negative 2.5 times 1 minus 2t to the power negative 4.5, and that is equal to 1 minus 2t to the power negative 10. And from the key crucial properties of the moment-generating functions that you must know for the exam, we know that the nth derivative of a moment-generating function of random variable z evaluated at t equal to 0 is equal to the nth moment of the underlying probability distribution. So in this case, E of x cubed is simply equal to the third derivative of mx of t evaluated at t equal to 0. So we take the first, second, and then third derivative. The first derivative would be negative 10 times negative 2 times 1 minus 2t to the negative 11. Then second derivative will be that negative 10 times negative 2 times negative 11 times negative 2 times 1 minus 2t to the negative 12. And then a derivative of that would be negative 12 times negative 2 times 1 minus 2t to the negative 13. So the third derivative overall is equal to negative 10 times negative 2 times negative 11 times negative 2 times negative 12 times negative 2 times 1 minus 2t to the negative 13th, and we evaluate this at t equal to 0. So if we plug in t equal to 0, the last expression becomes 1, and all we need to do is just multiply out negative 10, negative 2, negative 11, negative 2, negative 12, negative 2. And there are 6 negative signs, so this is positive. And we just need to multiply it out, and the answer is 10,560, which is answer E. Please remember, this is copyrighted material. The problem itself comes from a Society of Actuaries. The solution is mine. Good luck in your studies, and good luck on the test.